We don't need any other table. Not for this. I'll actually be giving you, just like I did up on the screen, I'll be giving you the chart for the binomial, so you won't have to worry about it.
I really struggle with this part, so
I will try to. Yes, I will. I will.
I thought we were given the meaning in the
These are Z. Z. Oh, do I have that? I might.
So those are Z-scores?
Those are Z-scores. They are.
Thank you.
All right, so check with your neighbors on your answers here, see what's going on, see if you get it all right. Is what a negative or a plus?
I subtracted one arbitrary, so I got a negative number.
Okay, and you know that's wrong because probability can't be negative.
1.2.
Generally, no, as a decimals. All right, Jackie, you got numbers for me?
The first one I have 0.0941.
Okay.
The second one I have 0.3264. And the third one 0.0918.
I'll give you the last one because I thought it's greater than your.
If I'm looking at positive 1.33, then I get 9082.
And then you take one.
I take 1 minus that, and I get that number. Now, as it turns out, for those of you that are, I don't know, looking for shortcuts all the time, if you have a greater than, you could interpret that as being the opposite of the negative, because a negative number is symmetric. It's symmetric on both sides. So greater than 1.33 is the same as less than negative 1.33. So if you look up negative 1.33, you'd get the direct answer.
Oh, really?
Yes, you would. But you know, some people think, you know, shortcuts are dangerous. You can get a flat tire and all this stuff. Yeah.
How'd you draw the first one?
The first one?
Yeah.
Okay, so what I'm looking at is I have 0 in the middle. I have 1.28 out here. I have 2.5 out here. What I want is what's in between.
Dang it. Okay, you're right.
All right, so there we go. Somebody's right.
Not me.
And so then to get that answer, you look up both of those numbers and get the table and subtract them. And the 2.5 will have the biggest probability. 1.28 will have the smaller one. If you subtract that order, you get that. So,
We're not gonna have one going out.
no. It's always going to be between. It's not going to be outside. Yeah. I mean, it's easy enough to do, but we're not going to.
I didn't get that answer.
The 941?
941.
Okay, what did you have for your z-score for 1.28?
I think that one was 0.3897.
No, it's not.
0.0668.
No.
Oh.
If I look up 1.28 on the table E, then, yeah, 0.8997.
Oh.
All right, any other questions about these problems right now?
What did you just say about that shortcut?
Oh, yes, if you're looking at something which is a greater than probability for a positive number, it's the same as the less than probability for a negative number. Because they're the same on both sides of the distribution, so you wouldn't have to do 1 minus that. You could just look at the negative number. All right, so there we are. So, Natasha, did you get these numbers, or did you? Okay. All right, so this is dealing with the binomial, or sorry, the normal distribution directly. But then we can also deal with it using data set. Okay. So let's say that ticket prices are bell-shaped, which they're not, but we'll pretend they are. Ticket prices are bell-shaped. And for a concert, concerts in La Crosse, we have a mean of $40 and standard deviation. Find probability.
Process abbreviate LAX.
Cheese bread.
True.
Get it together.
That could be Lucretia, that could. So, yeah. So then, find the probability for, price one more than $70 and less than. No, it's not 70. This is.
The true definition, right?
And less than.
Okay, now what I struggle with is how would you set that up as like how you did the one before, probability of Z being greater than or less than? So would number one be Z is greater than 65?
It's X greater than 65.
Oh.
Okay, because we're talking data values now. We don't have Z-scores yet. But this would be the probability that X is greater than 65. So now we need to change it into a Z-score problem.
Did you say this is data transformation?
Yes. I wasn't meaning to if I did, but yeah, that's it.
So in our other, never mind.
Okay.
So if we use that,
No, I better put another one up here just for fun. Less than. Yeah, because we didn't do that previously. Less than.
Or no, you went to try this
No, that's.
Yeah.
so if we were using the data transformation, which is what we're supposed to do, right?
That's correct.
How, what's my data value?
Your data value is the thing that's given to you in the problem that you're comparing. So the first one, the data value is 65. Well, sure. Why not put another one in here?
Would you change the dollar amount to the decimal point? Like, move it over to the left?
Would I change the dollar
I'm
amount?
just confused because in
No.
my notes, all I have is percents, not dollar amounts. So-
Okay, when you get to the end and you're doing probabilities, when you get done with the problem and you have a probability, you want it in decimal form. These numbers that I have right here are not going to change. These dollars are just dollars.
Okay, I'm confused where I get my. Stop. So, I'm trying to like, you don't do that. Because I did.
Okay, so I think you already answered this maybe. But so we don't take $65, make it into a decimal 0.65 and find the quotient of that.
No,
Okay,
that's not what we're doing at all. Okay, what we're doing right here is that we're finding probabilities. In order to find probabilities, in order to get the probability, I need to know what the z-score. For me to find the z-score, I have to use my data transformation.
And is the data transformation gonna be the?
Z is equal to x minus mu divided by c. The data value minus the mean divided by the standard deviation.
Oh, I don't do.
No. Then find the area, so does that change if it's less than or more than, do you also do the minus stuff?
Yes, depending on which direction you're looking for.
So if it's less than, like number one is more than, minus and then the opposite?
You would, because on the table, they only give you less than.
Okay, fine.
Yes. Just kidding, I found it. Oh my God.
We do too much of it. There's too many formulas at the same time.
You have no idea. But anyway,
I'm starting to get an idea.
yeah, you're getting an idea. There you go. You're starting to get the idea that you don't like this
I like
game.
this game.
That's right.
Okay.
That's the right answer. You don't like it.
Okay, here we go.
Does it make you happy to see but stressed?
Well, it does because I know that on the other end, you're just going to be so relaxed and happy that you're so successful.
Deep
So,
down, you know
yeah.
you're about to get a bunch of rides. That's what's happening.
Yeah, well, wouldn't hurt.
I have a question.
Sure, Kelly.
I just need to like number one.
5 minus 40 is
It is.
When 6 repeated. So do you
So what would you round off to?
You round it to 1.67?
Why?
Oh, why would I do that?
I guess that's the question. Do I have to round? Or do I have to-
What do you see on here?
But there's also a 1.6.
But what are you closer to?
Oh, this is, okay.
Yeah.
I feel a lot better about this.
See, that makes me feel better. You know, it's like you feel horrible and then you feel better and then I feel better. And then everything's good.
All of these formulas are starting to look the same. I don't know what I need the table.
Sorry, you have no idea. It's going to be even more that way in about a week.
I'm still on number one.
Yeah, I'm definitely still on the board.
I don't know where I was.
Well, when you get to number 4, tell me. Okay, so now what do I do with that?
So, okay, well, what is a more than less than?
More is if you draw your picture. It's really impressive that you can do statistics upside down.
Oh,
That
she's
is
like-
the picture. And then if it's more.
Oh, did I start my video? I think I did. Yeah, all right. I'm good. I am
Wait,
good.
what, how did you round the 1.6? I just did that. Oh, wait, I did mine. Wait, which one did you
Oh my God, are you kidding me? Thanks,
Are you sure you don't want this? Okay. I know, after. Mr. Powers.
Yeah.
Can you run through number 4?
Sure, when I get there. I'm not there yet, though.
Okay, yeah.
So 7, 4, 8.
Oh, I was like, why?
009.
That's just how. Oh, you just put 0
I did.
like that?
I did. Well, but technically I'm gonna put 0.
How are you?
Number 4 don't go that high.
I'm doing something. I said that.
It says on the bottom of the chart what you're supposed to
That's it. I just.
do. You gotta read the fine print.
Resources.
Gotta read the fine print.
Wait a second. Other side. Oh, yeah, then wouldn't it be point 999?
That's what 0.
Okay, so. After you 7 gives, you find the after fine. To get your actual, yep. Your actual answer is. See, I understand. That's what I'm wondering, so it's.
It is 0.99, but it's more than. So if it's more than, you subtract that from 1. So
Got it.
0, 0, 0.
Got it, wait.
No,
Wait, what?
for values more than 3.49, use 0.9999. This is 3.67. So it would be 0.9999 to the left, which would mean it's 0.0001 to the right.
How did you say you did number 4 again?
Okay, if we're out here,
Oh, use, I see it.
okay. So at 3.67, the table says this value to the left is 9999. So this value to the right would be 1. Which is basically 0.
I think that 5 chapters is a really, really lot for us to remember. I think putting the formulas in the area that we need to use them would be very helpful, because it's a lot.
To a certain extent, yes, it would be. To another extent, it would not. Because you have another however many chapters. So for us to say, well, we're going to divide it all up and put them all in the order that they're coming in, so that you would know exactly what order the situation is. So you don't have them just randomly scattered, but they're going to be in the order in which we went through them. And the formulas are also going to be in the order in which you're given. That's better than it would be otherwise, okay? And so that's as far as I'm going to go. All right, so as far as these things here that we have, hopefully you have those numbers. If you don't, then we need to find out why. So does anybody have any question about these numbers and where they come from? And pretty much we can ignore number 4 because that's an extreme situation, right?
Yeah, don't put that on the test.
Yeah, that would be crazy, wouldn't it? Put that on the
That'd
test?
be
That would
fun.
be crazy.
I could
So we're not going to do that. All right. So if you don't have any further questions about that, that's fine. How would we interpret these numbers?
In percentages?
It would be surprising if someone paid more than $65.
Oh.
It would be surprising if they paid less than $5, but it would be surprising if they paid 50.
Right. Okay, so a $50 price or $50 or less would not be a surprise. 65 or more would certainly be kind of a surprise, but less than $5, it's like, well, that's crazy. But the question you would have to ask, are these legitimate things? Is the mean actually 40? is the standard deviation actually 15? Is this actually bell-shaped? The answer to all three of those things is no. All right, so the fact that I'm giving you this problem is just pretending. But we're pretending that these are the correct numbers. All right, so then, what would be the z-score for the top 6% of that? This is one question. What is the z-score for the top 6%? And then the next thing I'm going to ask is, what would be the ticket price
Is it at the same
for
numbers you
the
gave us?
top 6%? Yep.
What is the z-score percentage?
You're supposed to do it really early, just say just do start with the higher one or the lower one. I'm sorry, what you think?
It doesn't matter.
I said, what is the z-score percentage?
What is the book? Yeah,
The book says do the higher one.
Oh, thank you.
Book did say do the higher one, yeah.
Thank you so much. Wow.
See, I so understand this more when the expenses that.
40.
What?
Did you like saying? I don't know, I had it in here. And then I moved it. So that's when you do this one. Oh, wait, no.
But since it didn't have like 7 I might get inside this. Okay, I did do that.
One minus.
What?
Thank you.
You said you do the higher one?
Hell yeah.
Yeah, we're on the wrong end. It's asking you to top 6, so you'll do 1 minus 0.06. And that will be number 6. So that, it was the bottom, that would be right. So the ticket price is this, that's 1 minus.
And we have 40.
Oh, it's so hard. So you do G40. Yep.
You would win.
So for me, it's always yeah, so that's the formula.
Okay, so
With that.
So this one's the.
And you find your data.
Yep.
No. You're gonna find the keys for.
Yeah.
Yes.
Yeah.
You have the
You gotta go right.
other stuff.
Yeah.
Where we did it.
So you.
Alright, so we.
Yes.
Yes. 840
And
and, oh,
060. Unless the number, if we would have had like 0.0 or 6.1%.
Oh my God. Starting to like now. Yes. Well,
But you gotta take one to find grade 6.
okay. Okay.
Thank you.
So then since it's $1, should we round up to whole number? Oh wait, rounding.
Yeah, there, great. Glad you figured that out. There we go.
We'll just make it cents.
Hmm.
Just say it's $63.40. Is that what you got? Yep. Okay.
63 and 40 cents.
$63.40.
So what do we do for the second part? What are we utilizing to find that?
Okay, we're gonna use the data transformation that goes back the other direction.
Right.
Yeah, your man will show you. But
Oh, it is.
I'm a little faster than I am, which is okay.
Yeah, I got that. But I didn't know. So that's.
Can you categorize the questions by data transformation and general probability?
Oh, yeah, no.
No. It's like, once I know what formula to use, I can input the stuff, but I just don't know when to use what formula.
Yeah, but they're in order, so I'll give you some help, won't
Okay, but remember what we're doing.
I? Okay.
Just know that I'm thoroughly unhappy with this.
And by the end, you'll be so happy, just imagine. All right. Emily Yang, you got a number for me?
I took one minus.
$1.56 and then $63.40. Those are possible answers. If you went with 155 and got $63.25, that would also be
How'd you
possible.
get money out of that?
Okay, so when we're using this and we have the 1.56 is the z-score, then this is a z-score. We want to transform this into a data value. So then that formula is this.
Oh my God.
So then this formula takes a z-score and makes it into data value. So then that's what we would do. And we would have $63.40. Or we use 1.55, we use $63.25. Neither of which would be considered to be the right answer
Did you just say neither of which?
in the big scheme of things. On a test, both of which would be the right answer.
Okay, stop with these hypotheticals.
Okay, so hypothetically though, if we were to ask the question, what is the real answer? The real answer is not 1.55, nor is it 1.56. It's 1.55477,359 approximately. And if you put that in there, you'd come up with $63.32.
Rounding doesn't matter.
But rounding doesn't matter really, so $63 would probably be a good enough answer.
Yeah, who's gonna charge
You know.
$40 for a ticket?
Okay, Eric? Okay.
I'm looking for 0.94, and I asked you this before, I don't remember what you said.
Okay, and the answer is, you're correct. You don't have 0.94, so what do you need?
Well, I have 0.394, and I have 0.9406. They're both six away.
Right, and so it doesn't matter which one you pick. It doesn't matter. It doesn't matter which one you pick. Because they're both close enough.
I feel like for statistics saying it doesn't matter is a lie. Because it definitely matters.
Well, the fact of the matter is, no, it definitely doesn't. Because all we're doing, okay, first of all, the only thing we're doing here is an exercise, right? So what we want to know is, do you understand the process? That's the thing. If you understand the process and you say, I found a number, that's close enough, that's good enough. Then we're done. Okay. So, no, it doesn't matter. All right, so let's try a different one here.
So what's,
Eric, you had a question?
I better not get
You had a question?
the last answer for the ticket price was $63.25,
Well, it could be 63 1/4 or 63.40, either way.
depending on which.
Which choice you make. And neither one is wrong. They are both right there. Okay. So, yeah, probably a good option then to go the other direction. So, now we're going to say that I'm going to be talking about,
Did you say this is something else?
this is something else.
Called what?
This is called, well, I haven't gotten there yet.
Oh.
I'm gonna write it up here and then you're gonna tell me what it is. See, that's how the test works. I don't tell you everything. You tell me stuff.
Is there
That's the
gonna
test
be,
is.
is there gonna be one of those questions where you have to add 0.5 because information's?
No.
Okay.
Okay, that's what
Because
I'm
that's
worried
super
about.
threw
Okay,
me off.
yeah,
That
that's
threw me
super
off,
confusing.
but-
Why do that? So we're not gonna. Okay.
Okay, that threw me off.
So the amount of sodium cracker. And cracker. And we're gonna say it has a mean of 40 grams, and a standard deviation of 7. Okay? So then the question is, what is the probability that a sample of 60 crackers has a mean less than 39? So what kind of a problem is this? A sampling distribution problem, because it uses the word sample and sample mean.
And all that last stuff we did was data transformation, even that last problem? The price and stuff?
The last problem that we did was finding,
For the top 6% ticket price?
yeah, that was finding data value for a percent. And we did use a data transformation for that, yes. There are 2 kinds of data transformation problems. That was the second kind.
Okay.
So is this the equals the x bar minus b over?
Yes, that's correct.
Wait, do we have to do these?
And it's 60 for the square root of n.
Yes, n is 60, so you put that in square root.
What numbers have you?
You just moved that.
My bad. Might be.
That's fine. Yes.
Oh, that's what happened. Okay.
She did.
And so if it said more than, you would find that area and minus it, right?
1 minus that area, yes.
Because less than is just that.
It's just that number.
Oh. Yes. Oh, wait.
You get your errors.
That's here.
60 is your height.
So what's your next
Yeah.
part?
That's far as the.
That's the 30.
Remember that.
Trees and people. And I thought that was.
All right, so the answer is 0.1335. This is negative 1.11.
Oh, I didn't round.
If I look at 1.11, this area is 35. This is 39 minus 40 divided by 7 over the square root of 60.
So why did you find the Z-score if the question asks for the probability?
In order to find probability, we have to use these. Because what's happening here is that just like the first problems we did after the break, if you're given a Z-score, you can find a probability. If you're, and so then we have to do a data transformation in order to make a Z-score here, in order to get the probability. So that's what this is. But it's the one where you use the sample mean. We're using the sample mean. The problem at the end of the test, which says sample mean on it, we'll use this formula to find the Z-score. And then you use that Z-score to find the probability. Question?
Wouldn't it actually be 4 with around 8?
Okay, if I do this, 39 minus 40, and I divide it by this, 7 divided by square root of 60, I need to not round that 60 square root off.
Yeah, I did.
Okay, so then
And then
what I got for an answer for that Z-score was not that number, but negative 1.106567.
Also went that round to negative 1.12.
It would not.
Why not?
This is negative 1.106. I look at this digit, the 0, and I say, do I leave it alone or do I make it go up? The answer is I make it go up because of the 6. So this becomes negative 1.11.
Oh, okay. I was just making
Okay.
a stupid mistake.
All right.
So when I put this in my calculator, like when I do the 7 divided by square root of 60, it gives me,
A big number with a lot of digits.
no,
Uh-huh.
gives me 7 square root of 15 over 30.
Oh, that's a problem on your calculator.
Parentheses.
So,
No, should I use parentheses?
well, there's a couple of things. First of all, your calculator is not ready to
At the beginning of class, it's
I don't
Okay. Please do not stay with one more problem.
All right. Anything else? Go.
Okay. I feel like that was more overwhelming than the learning.
You know, it's like jumping on top of the trash can to try to get more stuff in.
It is, well, it's, I just put it on the curb and everybody else deal with it. Not really.
Or I should say it's putting more ice cream into the cone. That's a better.
But ice cream from Troy almost statistics is not. I don't know where you get it, and not like more statistics in my brain. I didn't realize you had to apply for scholarships.
I do have a failure.
So are we gonna meet in the morning? We're gonna be on time this morning or 10?
Okie doke.